of theta. Can you get that from the picture? What do you have? It's 5 over 13, right? This will bounce back up in a second. So I fill that in for the sine of theta, and now I'm able to get the sine of 2 theta. It is 10 times 12 is a negative 120 over 169. Okay, because 13 squared is 169. So I have that. Negative 120 over 169. How about the cosine of 2 theta? Actually, there's a lot of forms for that. A lot of different ways you can write that identity. We had that one problem where there were 3 different ways of writing it. That's the one I remember, cosine squared minus sine squared. But if you did 1 minus 2 sine squared, that works also. Okay. So this is how I did it, and I put negative 12 thirteenths squared minus 5 thirteenths squared. And so let's see, I got 144 over 169 minus 25 over 169. So I know it's something over 169. And somebody was asking me, what's this deal with no calculator, Paul? I don't know. I think we should be able to do fractions. It's too bad it didn't say 145, because then the answer would be 120. So it's 119. Yeah, that's the mental math process I would use there. If you need to write it out more, you can. Okay. And to get the tangent of 2 theta, yes, there is an identity, but I think the easiest way to do it is the tangent of 2 theta is going to be the sine of 2 theta over the cosine of 2 theta. So you could just take these answers and put them over each other. I think that's the nicest way to do it. By the way, you don't want to write this. I've seen people do this for tangent of 2 theta. You see, you can't write sine or cosine without putting what's called the argument next to it. Don't do that. Matter of fact, a sine without an argument is a sin. We don't want to make that, right? So this 2 theta should be both places. Okay? And now what happens when you put this fraction over that fraction? Positive or negative? Negative. How about 120 over 119? Right? Because you can multiply top and bottom by 169. Hello? What's going on here? Okay. So, I guess the next... Oh, yeah, there goes that. Okay, so here we are. We have to do the sine of theta over 2 and the cosine of theta over 2. These are a little... They're called the half-angle identities. They're a little tricky. I mean, first of all, there's a plus or minus going on. You don't know... And where they come from is that we have identities for sine squared and cosine squared. So, you know, that could be a little tricky. And then the other thing is just remembering what they are. So this one is 1 minus the cosine of theta over 2, and this one is 1 plus the cosine of theta over 2. And so, well, let's see what I had to do. I guess all I have to do now is replace the cosine theta with what? What is the cosine of theta? I better bring my picture back. Negative 12 thirteenths, right? That was actually given. Okay? So let me work out each of these. This one is... Oh, and let me say one more thing. It has to be positive. But I want to show you how I know that. You see, theta is in quadrant 2. That means theta is between what and what?
Pi over 2 pi.
Yeah, it says theta is in quadrant 2. So theta is between pi over 2 and pi, right? So now I want to say something about theta over 2. So I'll divide everything by 2. What does theta over 2 have to be between? Pi over 2 and
Pi over 4.
pi over 4. And if you look on my picture where that is, here's pi over 2, here's pi over 4, right? So the theta over 2, I don't know where it is, but it's somewhere there in the first quadrant. You guys with me? Or was that too fast? All right. So we have plus the square root 1 minus, what are we going to put here, guys?
Negative 12 thirteenths.
Negative 12 thirteenths in there over 2. Whereas this one is going to be 1 plus negative 12 thirteenths over 2.
I thought you're supposed to, like, weren't we doing something with angles where we would, like, double it since it's getting divided by 2?
We did that. That was for this guy. I did that the other day in class. I drew pictures of this.
No, I mean, we'd have something, it would be like the cosine of 112.5 degrees. And obviously, like, on the unit circle, you wouldn't be able to find that.
Yeah.
But if you double that,
We still didn't finish either of these yet. Let's do it. Sine of theta over 2 equals the square root of, are you guys okay if I write it this way? 1/2 plus, and you see why it's plus? Okay. And then I have 12 thirteenths divided by 2. So maybe I write it as, I don't know. Yeah, see, that's not the best way to do this. Well, it's okay. It's 1/2 plus, and then 12 thirteenths divided by 2 would be 6 thirteenths. Yeah, that's ugly. So it's the square root of, this is 13 26ths plus 12 26ths. So it's the square root of 25 over 26. Okay? So if you put that, I'm okay. If you put 5 over the square root of 26, I'm okay with that. And if instead you put 5, what would it be? 5 radical 26 over 26. That'd be another way to do it, simplified. I would take any of these three answers as fine by me. Okay? Because they're all equivalent. So that's the sine. Hey, you know what? Cosine's easier. Let me finish the cosine right in here, in red. Cosine, because this is how many thirteenths if you want? 13 thirteenths are here, minus 12 thirteenths, right? So what you really have is the square root of 1/13 over 2 if you want. So it's the square root of 1/26. So you could write it as 1 over the square root of 26, or you could write it as the square root of 26 over 26. Any of those three ways are fine by me. Let me pause. Sure, I'm going to do sine over cosine for the tangent. So look, guys, I have 5 over the square root of 26 divided by 1 over the square root of 26. So the tangent ends up being 5. Okay, that's not hard. It's really the sines and cosines that I have to get. And let me do one more thing. Let me verify this identity with you. Okay? There's a lot of ways you could do this. Some people tried to use the fact that 1 plus tangent squared equals secant squared. And you can get away with that and actually do this pretty nicely. The problem was that some people thought 1 minus tangent squared was secant squared, and then that screwed up. Okay? I think that what the most common thing people did was this. 1 minus sine squared x over cosine squared x, and then 1 plus sine squared x over cosine squared x, right?
Oh, yeah.
That seems like a common thing people tried. But it's really ugly with all the fractions, right? So my advice is let's get rid of the ugliness. Can you think of a way to do that? Can you think of a way, what could I do to get rid of the ugliness? We're going to multiply the top and bottom by the same thing. We're going to multiply by, actually, cosine squared of x. Does that make sense to people?
Yeah.
Watch what I get. Of course, you'll have to distribute, right? So in the numerator, I'm going to get cosine squared x, when I distribute here, minus what? Sine squared x. Does that make sense? Okay. And then what am I going to get on the bottom?
Cosine squared x plus...
Cosine squared x plus sine squared x. Okay. Do either of those ring a bell? The bottom one equals 1. Right? That's the Pythagorean identity. And what I was really hoping is that the top one would ring a bell also. Do you know what cosine squared minus sine squared is equal to?
Cosine of 2 theta.
It's what we want. It's the cosine of 2x. So that's a way to do problem 2. Like I said, there's other things you can do too. This might be the easiest of the approaches I've seen. So I just want to point out, if you need more practice over the break, say before our next reattempt at this, here are some great exercises to try. These were on homework 6. Okay? And Caitlin pointed out that number 49, there's a slight twist that you want to deal with here. So I'll tell you what, why don't we start out trying 49, and I don't think we'll do the whole thing, but we'll at least do what she's talking about. So it tells me the sine of theta is negative 7 over 25. What does this tell me about theta? This tells me what quadrant I'm in, right? What quadrant are we in? 3 pi over 2 less than theta less than 2 pi. We're down here, right? In quadrant 4 somewhere. So when I draw my picture of theta, which you can't see right now, sorry about that. Let me try and fix that. Okay. So theta is between 3 pi over 2 and 2 pi, and they told me that the sine of theta is negative 7 over 25. So that's what my picture looks like. I'm going down, so I write negative 7. And you've seen this right triangle enough by now to know that you could get this side here, right? That one is 24. If not, you have to do the Pythagorean theorem to get that. So that takes time. I'm making this all look easy. I understand that. So then, for example, do you want me to find the sine of theta over 2 or the cosine of theta over 2? Maybe we'll do both. You have preference? Cosine? Okay. Let's find the cosine of theta over 2. Now the cosine of theta over 2, the formula says plus or minus square root of 1 plus cosine theta all over 2. Right? That's the formula. All right, so I'll try and use it. But what Caitlin's question was is, hey, what's the deal with plus or minus? How do you know which one to use? And that's where I said, we know that this is true about theta. What we really have to do is say something about theta over 2. So I'm going to write theta over 2 is less than what? Less than pi. You guys with me on that? and it's greater than
3 pi
3 pi over
over 4.
4. Let me draw a picture of where theta over 2 would be. I know it's less than pi and greater than 3 pi over 4. So actually, this should make some sense to you that theta divided by 2 is a smaller angle. And so if theta is in quadrant 4, it kind of makes some sense that theta over 2 would be somewhere in quadrant 2. Doesn't it? That make sense to people? So I know theta over 2 is somewhere over here. That answers the question about cosine and about sine. Remember, sine has the same thing. 1 minus cosine theta over 2. So when you're trying to figure out which one to use, if I was talking about the sine of theta over 2, I would choose positive. But if I'm talking about the cosine of theta over 2, I would choose negative. Does that make sense to people? It has to do with the picture of where theta over 2 is. Caitlin, I don't know a better way to show you than just to show you that picture. Does that make sense? How did I get the picture? I got it from what was given about theta, and then what did I do to get from here to here? Divide everything by 2. So that tells me where I am, and this means we are definitely in quadrant 2. And since we're in quadrant 2, cosines are negative there. Okay? So the answer would be 1 plus, what are we going to put in for cosine of theta, guys? 24 25ths. Then we have to divide the whole thing by 2. And the answer is negative. Okay. That's enough on that.